good topic, which was the deep sea. So we're going to talk all about that. And I'm really, really happy that this actually got chosen out of the blue. Because I've had these old books for quite a while sitting up there on my shelf. And it's given me the opportunity to use them, dive deep into them. So let's find out about this deep sea. Let's see, where are we? Let's find our place. Cool. Here we go. Oh, wait, first. So, we have a cool little picture. The blue planet. And a quote by Ecclesiastes. That which is far off and exceedingly deep, who can find it out? Who can find it out? Well, hopefully us today. So, Chapter 2, The Blue Planet. And I think this was a book from a series kind of like Planet Earth from the BBC, and that might have actually been a remake of this, because it said on the cover that it was from a PBS series, so that's kind of why I liked it. It was very accessible to the public, so let's find out what's in it. Says, viewed from a spot above the center of the Pacific, looking down upon the Marquesas or Samoa or Phoenix Islands, the globe is almost all blue, like a sky filled with few clouds on the far horizon. The surface of our world is nearly 3/4 water, and therefore, and there are those who think it should be called planet ocean, meaning the water planet instead of the dirt planet. The northern hemisphere is 50% water. The southern hemisphere is 90%. And we call these waters the Indian, the Arctic, the Antarctic, the North and South Atlantic, and the North and South Pacific. But they are all linked. Water circulates between them. The continents are merely islands in one vast ocean. The Pacific Ocean alone is larger in area than all the land on Earth. No other world in our solar system has an ocean of water. At least that we know of yet. Maybe one of the moons might. In ancient Greece, Aristotle taught that the world was made of just 4 elements: water, earth, air, and fire. Today, the scientists have identified many times that number of chemical elements, but modern scientists, when they look at planet Earth, they still like to speak of 4 fundamental elements. Those being the spheres from solid Earth, which is the lithosphere, like megalithic. Lithic meaning rock or stone. The water, the hydrosphere. Then third, the atmosphere. The air. And then the fourth is the life or biosphere. And the hydrosphere, of course, is what we're talking about today. And it works immediately with the other three elements. 97% of the water on the planet is in the ocean. And of course, the ocean is key to the vagaries of our weather and climate. For all these reasons, the ocean will help us decide whether our planet remains habitable. I thought that was a nice little introduction. I think there was one other thing I read. So there we go. The ocean, like the solid earth, was once thought to be static. Though its surface was stirred by currents and rippled by winds, the deeps were supposed to be still, dark, and silent as the grave. And they were stagnant wastes, like Davy Jones's locker. But the world ocean is proving to be like the solid earth. The closer we get, the more restless it looks, alive with currents and gyres from top to bottom, Oceanographers using futuristic ships, submarines, robot buoys, and even satellites are discovering more and more profound and exotic turbulence and swirling brushstrokes like those of Vincent van Gogh. You'll see a really cool picture in actual satellite imagery. Looked. Where was it? Here we go, look at this. And you can see right there, it looks like these swirling eddy currents. Almost look like something out of a Van Gogh painting. The Starry Night. The Shimmering Ocean. I hope that's not blurry, but either way, I was really impressed with it. So I wanted to just bring that up, briefly show you something about the ocean currents, because they're so fundamental to the ecosystem of the ocean, the hydrosphere, I guess it's called. And just because I really like history, I really like history. The earliest sailors sensed that the world's lands were surrounded by water before they ever knew there were 7 seas and 7 continents. One of the first attempts, of course, those are arbitrary terms, I guess, because in that book, Our Oriental Heritage by Will Durant, he speaks of Europe being merely a minor outcrop, a minor peninsula outcrop from Asia. So Asia's the real mass, and it's like Europe is to Florida, Europe is to Asia what Florida is to the U.S. One of the first attempts to portray the whole earth, a Babylonian clay tablet, 3,000 years old, shows the world as a disk with a band of water around it, with Babylon, of course, at the center. And the Greeks spoke of a great stream of ocean that encircles the earth, with Greece at its center. In the Christian Europe in the Middle Ages, the most common scheme for a world map was the orbis terrarium. And this religious conception of planet Earth shows the Don River in Russia, the Nile River in Africa, in the Mediterranean Sea, all in one, in the form of a great T. I guess that's it. A crucifix. And I guess that's it right there. If you can see it. And there's Africa up there. But anyways, I guess I could elaborate on that, but we're talking about the deep sea right now. And, I love the sound of books. Shout out to Sarai, Peace and Soriety, ASMR. She's so awesome, and she just had a book, her summer reading collection, by the way. I go check that out. She is so gentle. It really put me to sleep like super quick. So gentle with her. Of course, she has fingernails. Maybe I need to just get some acrylics, because I really love that sound. But I want to do I'll pull you in to the concept of ocean currents, because with the fact that there are, just like there are breezes and great trade winds on a global scale, there are ocean currents on a global scale. Of course, you have tides that ebb and flow, but there are currents that take, some of the most deep currents that take up to 1,000 years to circumnavigate the ocean. So the ocean's currents flow like a global conveyor belt, great distances, which play a dominant role in determining the climate of many of Earth's regions. And more specifically, ocean currents influence temperature of the regions through which they travel. So they influence the temperature because they bring mass quantities of warm or cold water, which of course changes the surface temperature of the air touching them. So one of the most tangible examples for me is the Gulf Stream, because I'm in Florida, and the Gulf Stream makes it makes Northwest Europe much more temperate, which means temperate or tepid climates, which means, thank God for Wikipedia, it's the middle zone. Zones which have temperature ranges throughout the year and more distinct seasonal changes compared to tropical climates. So, okay, that makes sense. It's kind of like I'm on the threshold of being in a really tropical climate, because our temperature drops into the 60s Fahrenheit, maybe the mid-teens Celsius during the winter, but roughly the ocean currents, for sure, the Gulf Stream that goes by my back door here, it never gets cold enough down here in South Florida to need a wetsuit, for instance. So the Gulf Gulf Stream, and I'm about to show you a little video, a satellite view. I guess it's an animation, I think, but it makes the Gulf Stream makes Northwest Europe, Scandinavia, England, France, makes it more temperate than any other region of the same latitude. So it definitely affects it. In this really cool video, check it out. Super low production quality here. I'm just gonna point my camera at it. Alright, so you see this. Let me move that. The perpetual ocean. So there, right there. I have to hold the camera steady or else I'd point to it, but you see the eastern coast of Florida where that little lake is. That's pretty much exactly where I am. And this warm ocean water goes across the equator, up through the Caribbean. And now we're going down south, and look at all those giant swirls. I mean, those things are hundreds of miles across. And there's that huge warm equatorial currents that go between, what's that, Tasmania and South Africa. And of course, all through the Indian Ocean. I always think of the Indian Ocean as being really, really hot. Really warm. And then here's Indonesia, Southeast Asia, Malaysia. And apparently this current here going up past Japan is something like the Hiroshima or something. I know I'm getting that wrong, but that's the largest current in the entire world. And so you see here, I can pause it for a second. Here, the eastern, there's an eastern flowing equatorial current that divides and goes south and then north. And you'll see a bigger picture, but the northern one just goes in a big circle up to Russia and back to Alaska and circulates, and then this one goes south along the South American border to Antarctica and then over to Australia and circulates like that. And sorry about the shaky camera action. You can find this by typing NASA Gulf Stream current. And then here we have Antarctica, which you can see by following the white eddy current lines. It is essentially entirely surrounded, circumvented or something. Circumambulated, I think they might be called, by really cold ocean currents. And then here's the huge westerly. Yeah, that was the westerly, South and North Pacific currents. So anyways, guys, I hope that was somewhat interesting to you. Let's see. So it was really cool. The reason I wanted to mention this was because I'm about to talk about the deep layers real quick and tell you a little story about these guys who
enormous pressure. They didn't expect to find anything. But there's a plot twist. There's a plot twist. I'll give it away. They did find something.
The surface. Okay. So there's something called a thermohaline circulation.
Okay, so I wanted to show you this. Thermohaline. Thermo meaning heat. Haline being derived from the word for salt. As you can see, the Great Current is on the surface. As it goes up the eastern coast of America, then it goes up to Greenland and drops deep, 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 deep because it gets cold. So it's initially hot and then drops down to the deep ocean.
And then you can see it goes down the mid-Atlantic, underneath that hot kind of highway coming from Africa, and then down to the Antarctic. And this whole process takes 1,000 years. And it's all connected. And I think it's so interesting. It's so interesting that if you give a couple thousand years, a particle can make it entirely around the world, through the Atlantic, the Pacific. There's some modest mouse for you. Okay. So the whole point I was getting at was to show you that there's these massive, massive global, long-term currents. And their purpose, one of their purposes, other than mediating temperatures and well, is to keep contents stirred up and to keep the consistent spreading of, it's not their purpose, but it's a function they serve. It spreads food and algae and all the living things and nutrients all around the world. So, let me tell you a quick story. And it's an old book, so don't worry. I got it cheap at Goodwill. Don't worry that I dog-eared it. Let's see. So, Benjamin Franklin, you can see here, was well aware of the Gulf Stream current running up the north, through the northeast of the Atlantic, from the west, along the eastern coastline of America. And, of course, the English and Europeans traveling the ocean, the Atlantic, were very much aware of which direction let me show you this. They were very much aware of the constant circular motion of the North Atlantic. Helped ships travel. So I think it's really fascinating that the ocean is so much more alive and yet consistent than I would have thought. There's these massive structures, these massive whorls, hundreds of miles wide in them. And, so 1877, which is not as old when this book was written. Scientists, aquanauts, of course, because this was written when the moon landing was still pretty fresh in everybody's mind. So aquanauts, astronauts, trying to be cool. But they are actually really cool. They had set out to settle a question about the mid-ocean ridge. And what they thought that, and this is really another fascinating thing about our knowledge, our scientific, understanding of the world, is that it's so young. We're still so ignorant about how the world works. And I think it's really easy to get haughty and arrogant and think that we understand everything, to forget just how much we don't know. I'm getting at the fact that plate tectonics was a theory that was only less than 15 years old. 15 years old, guys. Because it's taught in textbooks in middle school and elementary school even nowadays, as though it's always been common knowledge, and we're missing the historical context of how novel of a concept it really is. So these guys actually dropped what's called thermistors, which just means a little electronic device that can, or analog device that measures temperature. And they were trying to affirm a theory that that the mid-Atlantic ridge that runs north and south right up the middle of the Atlantic, that it was getting hotter and hotter towards the middle, where the plates theoretically should have been connecting, or at least overlapping. And these measurements were going to confirm the plate. So they were in the process of still confirming the plate tectonic theory. And there, the floor should have been hot as the curve of ascending heat abruptly fell off. So it was a mystery, because when they went to measure it, they got progressively closer. And it was getting hotter and hotter and hotter. But then, when they actually got on top of it, the heat signature disappeared. It disappeared completely. What was this? What was damping the fires at the ridge? And then the second mystery that this ties into is the background of the deep sea exploration. I will get to it eventually. So, I hope to God I don't name this episode 100% deep sea, because it's obviously mostly currents. But obviously there's a lot more to explore. So there was a second mystery, and this one was centuries old. All over the world, James Hutton was the first to recognize rains and rivers are forever wearing away. The rock in continents, and carrying loads, tons and metric miles of tons of debris and silt into lakes and down into the sea. The runoff is full of minerals, including salts and bicarbonate and chemicals produced in great quantities when rainwater weathers limestone. Some lakes have inlets but no outlets, no escaping streams, so the only way water can depart is by evaporation, and in doing so the water leaves behind its load of minerals. So we have mineral salts and bicarbonates accumulate create, a great salt lake. So they create a
Great Salt Lake, or the Soda Lake, or the Dead Sea,
in which virtually nothing can grow. The world ocean itself is sort of like a sunken giant lake, all inlets, no outlets, So all roads lead to Rome, all flowing rivers end at the sea. Yet the ocean is not choked full of bicarbonates, and
though it is, of course, salty, its minerals are not in the ratios one would expect to find, given the chemistry of the waters that feed it.
so the question was, why isn't the ocean a vast Dead Sea? Which is pretty interesting. In 1965, when the theory of plate tectonics was taking shape but not yet respectable, so 1965, when we were just about to land on the moon, plate tectonics wasn't even really verified and was not even widely accepted as having conclusive evidence for its existence. John W. Elder, in 1965, British geologist John W. Elder made a shrewd suggestion. On land, he observed, there are places where magma lies, pooled near the surface, and groundwater seeping down,
Touches red, hot rock, and boils back up to the surface.
In New Zealand, such hot springs supply enough energy for a hydrothermal power plant. And one of the first of its kind in the world. In the United States,
We have Yellowstone National Park, where we have Old Faithful.
so Elder thought there might be hot springs in the deeps along the mid-ocean ridge. So their ice-cold seawater might meander down through the cracks and fissures and meet magma and explode upward in furious old faithfuls. Because the magma was cooled by the seawater, less heat would flow up through the seafloor's sediments. What is more, seawater superheated in the fissures of basalt would exchange chemicals with the rock. Bicarbonate in the water would fizz into potentially carbon dioxide, and the hidden fires and cauldrons would keep the sea's chemistry in balance.
They would keep the seas alive.
So in 1973, 4 years after the first men landed on the moon, scientists in tiny submarines made their way down for the first time into the Rift Valley of the mid-Atlantic Ocean ridge. There they found frozen beds of basalt, twisted in the same strange, swirling, ropey shapes that lava makes when they cool on land. Eerie fields of black, tormented stone that the Polynesians called Penhoho. This was a great discovery. It proved that eruptions do occur from time to time along the mid-ocean ridge. As a theory of plate tectonics had predicted. But the scientists and aquanauts did not see any hot water jetting up from the basalt. Apparently they had landed on a dormant spot. So in search of a live vent, they went all the way to the Pacific, since its ridge is livelier and more fiery than the Atlantic's.
And the scientists actually chose to go to the Galapagos Rift, near where Charles Darwin had went ashore 100 years earlier on the HMS Beagle, and watched cormorants and sea lions, and hitched a ride on the back of a giant tortoise.
I didn't know he did that. On that voyage, Darwin was the only scientist, and there were some 30 scientists on this one. The Nor, which surveyed the land before the divers began, and the Lulu, which carried the submarine Alvin, is what they used. So there was lots of people, and they dropped down to 7,500 feet of water, which, divide by 3, I guess that's 2,500 meters, something like that.
Sorry, my stomach's really hungry.
So they were picking up all these rock samples, and it was kind of boring, like the Atlantic trip was. And then they stopped to pick up one rock sample with Alvin's remote-controlled mechanical arm, and the pilot wrestled with the manipulator. They began to lose interest in the rock, when at the same instant, both noticed intervening water.
Water, it was shimmering like the air above hot fire.
So instantly they dropped the basalt and went up the slope, and there they came upon this spectacle that no one, not even Elder, had expected. Spread out upon the basalt were dense
masses of giant mussels, clams the size of dinner plates, white crabs scuttling among them, and strange, colorful fish they couldn't identify. It was nothing less than an oasis.
And the people back on the ship thought there was something wrong with the submarine because they were so ecstatic, and when you're especially down in those depths, you get what's called narcosis, and you immediately, the first stage indication that you're succumbing to narcosis is feeling like you're drunk, and it's an immediate, pretty much near immediate feeling of euphoria, so people, you kind of go crazy, and then you're gonna black out shortly after that. So
obviously obviously the people watching over them were concerned, thinking that this was happening.
But in reality, they were just really, really excited.
Okay.
So following their first delirious discovery, the expedition scientists made dive after dive in the Alvin. They found 5 separate oases, which they dubbed Clambake 1, 2, Dandelion Patch, Oyster Bed, and the Garden of Eden. And now
The sights were easy to spot. So once they kind of understood the patterns they were looking for, they kept going down and down.
seen from above, the ring of white clams stands out against the black like a halo. At each site Hot, milky, shimmering water rose from the vents and fissures in the floor. Shellfish clustered around the warmest vents, all but choking the flow of hot water. And feather duster worms browsed, along with brittle stars, purple anemones, and wavy fronds. A few black basalt pillows were draped with something white and stringy, which looked like masses of spaghetti, which
I found out, by the way. Quick side note: the singular of spaghetti is spaghetto. I thought that was funny.
So it was just another deep sea worm. Above the heads of all these creatures swayed the strangest creatures of them all. Giant worms. And they looked like blood-red tulips, 4 to 10 feet tall, with stems as white as chalk. So the Oases was a secret archipelago, as strange as and full of marvels as Darwin's beloved Galapagos.
So this says these giant tube worms. It says these giant tube worms are sustained by not by the sun, but the heat of the earth itself.
Alright guys, well, that's about all the time I have for this today. Sorry if I didn't get to the deep sea as much as you wanted, but I'm really, really grateful that so many of you guys participated in the poll. I really hope this was a fun interaction, so I wanted to jump right on it and get it done and put out Friday night, hopefully tonight.
I just said that. I really got myself I committed myself pretty thoroughly there.
But with any luck, it's Friday night and you're watching this, and you were one of the people, the 90 or so people who upvoted that, and I really hope you guys liked it.
Thanks as always to all my Patreon supporters, and I want to give a special shout out to Romachek, who supported, threw a huge $100 donation in my live chat the other day. Romachek 75. So you said you don't comment a lot, and I've never seen you comment, and it just really means a lot that you would support me in such a huge way. So I felt bad because it was in the middle of the live chat stream, and I had to go back and dig through it to find out who you were again, because you were like one and done. So yeah, and then of course the